Hello. We're in the living room now. My daughter has kicked me out of the kitchen. So we're going to try this on top of the fireplace. So we have our little screen. And we're going to do 97 about more distance rate problems. So just to remind you, we have miles per hour, which is distance over time. And this equals rate. So one easy way to remember it, and you'll hear this a lot in, I guess, physics, maybe? dt equals r. If you want to bring the r over there, you could say distance equals rate times time. Or you could put the r over here and say time is distance per rate. Okay, well, we're getting a little tiny bit ahead of ourselves, just to like bring you up to speed. So this problem has to do with a train, high-speed train, that's traveling 300 miles an hour. 300 miles, excuse me, in 1.2 miles, in 1.2 hours. So 20% of an hour is 12 minutes. So 1 hour and 12 minutes. Lewis and Omar are trying to figure out how they can find the distance the train has traveled after any number of hours. So they want an expression. Omar decided to draw a diagram to help figure out the problem. He drew the diagram below. This is a very interesting diagram. So he starts at 0 hours and he goes to t time, this is an unknown, and d in miles. This is in hours? Yeah. So he is gonna like draw these weird little circle things, and he's gonna say in 1.2 hours, his train goes 300 miles. And then for some reason he draws two of those. I have no idea why. This is another 300 miles in another 1.2 hours. So now we're up to 2.4 hours with these two circles. Well, that's okay. I mean, he's thinking of it the way it makes sense to him, which I think is actually pretty noble. Find a unit rate in miles per hour for the train, then copy and change Omar's drawing to show the unit rate. So it's already pretty much done for us. We just have to use our calculator to divide 300, is this showing up? Miles in 1.2 hours. We want it just to be 1 hour. So if we just divide those straight up, we'll get rid of that 1.2 hour. So we have 300 divided by 1.2 is 250. So the train is going to go 250 miles in 1 hour. You don't really even need to write that 1 hour. It's kind of implied. So now on his groovy little graph, we're going to just put, I think this would be better, 250 miles, 1 hour. In hour 2, he's gone 500 miles. In hour 3, he's gone 750 miles. Shh, Eddie, Izzy. Okay, so how far will the train, so we've done A, we've recopied our diagram, and now we're going to see how far will the train travel in 5 hours. So I could actually extend my diagram for 2 more jumps, 4 hour and 5 hour. So 750 plus 250 is 1,000. And then 1 more set of 250 in 5 hours. So in 5 hours, write an equation to represent how far the train will go. We'll go in d miles after t hours. So our equation is going to look like distance equals 250 miles times time. So if you're and it has to be in hours, can't be in seconds or minutes or anything. So if you are going on your train for an hour, you're gonna plug a 1 in there and you're gonna get 250. So 1 times 250 is 250. If you're going 2 hours, you're gonna plug a 2 in there and you're gonna get 500. you're going 3 hours, you're going to plug a 3 and you're going to get 750. 4 hours, you're going to get 4 times 250, which is 1,000 miles, pardon. And 5 hours, you're going to get 1,250 miles, 1,250. Work with your team to write the general equation showing the relationships between distance, D, rate, R, and T time. So more than one way to represent this relation. So that's what I talked about in the beginning. Distance equals rate times time. And you can switch any number of those around. You can say, you can even write it like this, rate is distance per time. Those are the two I mostly use, have used. Figuring out physics problems and whatnot. Okay, so where are we on time? Where do we find that? 7 minutes. So I think we can finish up with 98 in this video. In problem 97, you wrote an equation to relate distance to rate of travel and time traveled. What if the rate does not involve distance? So we don't have to have a distance here. It could be something you do per time. You wash your teeth twice a day, can be a rate. 2 teeth brushing per day. So here we have Fred. I'm covering Fred's little face. There's Fred filling a bag. Oh, and he doesn't have his gloves on or a mask. COVID joke. Fred was filling bags of food for families in need at the neighborhood food pantry. Fred could fill 6 bags in 15 minutes. So let's write that down. Let's write down the English. 6 bags in 15 minutes. And we know how many minutes are in an hour. We know there's 60 minutes in an hour. So if I multiply this by 4, the big one of 4, I would get an hour on the bottom, wouldn't I? Think. Yes. So we can say he does 24 bags in an hour. That's going to give us our unit rate. Doesn't seem like that many bags. Okay. I don't know. Never been a bagger. Draw a diagram for the situation and be ready to explain how you found your solutions. Okay. So how many big bags could he fill in 2 hours? So if he could do 24 bags in 1 hour, in 2 hours, we're going to multiply this by 2. So we're going to get 48 bags in 2 hours. And for B, it says, how many bags can he fill in 5/6 of an hour? What strategy did you use to find this answer? So we are going to multiply by 5/6. So we have 24 bags in an hour. And we want to know 5/6 over 5/6, basically. 5/6 of an hour. So 24 times 5/6 is, let's say, I'm going to just multiply 24 by 5, and then I'm going to divide that answer by 6. And I'm going to get 20 bags, which sounds about right, because if he does 24 in an hour, he does a little tiny bit less, does 4 bags less in taking a 6 of an hour out. Is that right? Let's check. Yes, it is right. Thank God. Okay, moving on to C. Write a rule to generalize the relationship between the number of bags Fred can fill and the amount of time that he works. Be sure to define your variables. Okay, so let's define our variables. Let's let B be the number of bags. Let B equal bags, number of bags. Let's let T be the time. Let T equal time in minutes. And what else do we need? Oh, that's all we need. So here's our variables we're going to use. We're going to use B and T. And we're going to say B bags equals 24. Is this in minutes or hours? This is in hours. My bad. So B equals 24 times time. That's how many bags he can stuff. So it's 1 hour, he can do 24. If it's 2 hours, he can do 48. If it's 3, he can do 72. If it's 4, he can do 96. And so on and so on and so on. Okay, use your equation to find out the number of bags during a week. 36 hours a week. So we're just gonna put a 36 in for our time. 24 times 36 hours. Now that sounds like a lot of bags. Finally, he's making some money. Oops. 24 times 36. What? Okay, that one, first one wasn't right. 864. 864 bags. That sounds kind of monotonous, doesn't it? Okay, so thank you for your attention, and I will see you on the next video. Oh, I'm out of batteries. Okay, love you guys. Bye-bye.